already. Make sure you've got your calculators and make sure you've got your L4 out, which you all seem to do, which is great. Does anyone not have their L4 with them today for any reason? Yeah, like your L4 notes. Yeah. Yeah. So just make sure you're kind of on L4 right now and that you've got your calculator because you'll be using that a fair bit. I should probably open mine too, shouldn't I? Let's get mine open. Oh no! And if you need a new calculator, we don't sell them from the school anymore. You just have to buy them somewhere. I'd suggest Amazon. Amazon's kind of faster and cheaper. I would get the one that everyone's using. I would suggest that. And also the one you're used to. You're used to the one that you've got. So that's the thing. Like you know how to use it pretty well. Okay, cool. So finding just one term of a binomial expansion is what we're doing now. Where did that? I just want to make sure that little recording thing's up because Talise is not here today, so we're recording for Talise. So just reading vaguely over what we did beforehand. This was, as I said, the most popular topic, and you'll find on your topic assignment, finding one term is almost the entire topic assignment. Like they constantly are asking you to find one term. I think it's only the first page and maybe another question where they don't ask you to find one term. Why do you think it's the case to find just one term? And as you kind of pointed out, it's less effort for the examiners to mark if there's just one term that you need to find as opposed to like 6 terms or an entire expansion. So this was a straightforward one, I think, like, you know, find the x cubed term in the following, and it's x minus 3 to the power of 5. So the x cubed term, so something like this, when you start to expand it, remember the first term would have an x5 in it, the power of x would be 5. The next one would be x4, x3. There'd be coefficients at the front, but that doesn't matter. We just want to know where would the x cubed term start to appear. So we kind of, if you're not sure, you can kind of start to write it out. First one would be x5, x4, x3, x2, x1, x0. And then not forgetting that the first binomial coefficient would be 5, 0. So NCR would be 5C0, 5, 1, 5, 2. So by accident, some people might think it's 5, 3. But if you can kind of remember, some of you when you're starting out, practice writing it out like that. And then that might jog your memory that it starts with 5, 0 and it's going to end with 5, 5. Because if you by accident started with 5, 1, you'd pick up on that because you would have gone to 5, 6 and you know that that's not possible. It's got to end with 5, 5. So we use 5, 2 as our binomial coefficient, NR. So we put in 5, 2. We like to show this, as we said, the examiners like to see this brackety part here, 5, 2. And if it's the x cubed term, then of course this one's going to be to the power of 3. And negative 3 must be squared, because this plus this must add up to 5. Yeah, good. So, and then you just work out what that is. We practice using the gorgeous formula, this one here, NR equals n factorial over r factorial n minus r factorial. So on this page we practice doing it by hand as if it was non-calc. So it'd be 5 factorial, n factorial, over r factorial, and 5 minus r, n minus r factorial, which you find a lot of cancelling down happens. Negative 3 squared is just 9. And then 5 times 4, blah, blah. And then 2 factorial, and then we've got 3 factorial. Heaps of stuff cancels down, so you end up with just 5 times 4 over 2 times 1, which gave us 10. And so 10x cubed, don't forget it's still times 9 here. So when we multiply all this out, we ended up with 90x cubed. And again, always double check, is it wanting the term or is it wanting the coefficient? Because you don't want to write that as your answer, and all they wanted to know was the number 90. So they test you on that a bit. They alternate between asking for the term or for the coefficient. If they want the term, you've got to have the x in there as well, and the exponent. Then we did this one as well. As I said, on my copy, it's asked me to find the x fifth term, but on your copy, it's the x cubed term. So that's where I was getting confused in the last lesson. But this answer here is right for the x cubed term. So the first one, notice x is here, so it's descending powers of x, whereas it would be ascending powers of y if they're asking for the y cubed term. So descending powers of x, so x8, 7, 6, 5, 4, 3. I just stopped when I went to 3. If it was asking for y, you'd be starting with y0, then y1, y2, y3, y cubed, sorry, y to the power of 4, and so on. Oh. Yeah, so descending powers of the first term, and ascending powers of the second term, in case you were suddenly asked for the y to the power of 6 term, for example. You'd be using y0, y1, y to the squared, y cubed, y to the 4. If it really bothered you, you could just swap them over, and then you know it's just ascending. If you've got the one you want, put it first if you like. So again, like pointing out that it starts with 8, 0, 8, 1, and then R will be 0, 1, 2, 3, 4, 5. So that's how we knew it was 8, 5. So by writing this out, it meant I didn't make a mistake and suddenly go, oh, it's 8, 3. So writing it out to begin with is, and even in the exam, is a way of kind of avoiding kind of making that kind of mistake. And then so 8, 5 is our NCR, and then we've got 2x to the power of 3, because it was the question's asking for x to the power of 3 at the top. And then therefore 5x to the power of 5, because these two must add up to 8. Then you can write out your little gorgeous formula, 8 factorial over r factorial n minus r factorial. 2x cubed, as you pointed out, is 8x cubed. 5x to the power of 5, 5 to the power of 5 you found was 3125, y to the power of 5. Practicing using the gorgeous formula again, just on this page, lots of cancelling down happened. We're able to cancel down all the yellows, and with the black I was able to cancel down 6 over 3 cancelled down to 2, and 8 over 2 cancelled down to 4. Just made life easier. We end up with 56. 8 times 3125 gave us that, and then you end up with this big coefficient. So you are going to get answers where you've got big coefficients going on. It is quite normal to get answers with big numbers going on here. X cubed y5. So just going over, they're pretty straight up questions. I think maybe the front page of the topic assignment has some questions like that. And also another thing, just a little flashback. If it's to the power of 5, how many terms would there be in the entire expansion? 6, good, yep. So power of 8, how many terms would there be in the entire expansion?
9.
9, yeah, good. So that's another thing that you'll probably find on the first page of the topic assignment. Some nice easy questions like that. Then similar one to the front page of the topic assignment. Find the 7th term, but it just had awkward terms like 3x, 4 over x squared. It was a little bit trickier to work out exactly what the power of x would be, but it's fine, they weren't asking for us. So I just want the 7th term. So 7th term, so if it helps, write it out. 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. If you count up, 1, 2, 3, 4, 5, 6, 7. It's this one, it's 14, 6. If you just kind of guessed off the top of your head, sometimes people say by mistake it's 14, 7. So writing it out painfully like this doesn't take too long, and it can avoid you making that kind of mistake by just thinking it's 14, 7. It's because you start at 0 here. R starts at 0. So the 7th term will actually be 14, 6. So 14, 6 is our little coefficient. The 7th term, if you're not sure, what will be the power of 8 of x? It's descending powers of x, so x 14, 13, 12, 11, 10, 9, 8. See, it matches up with 8. And did you notice that when we did that, this number here happens to be that minus that. N minus r happens to be that little exponent there. If you're not sure, you can kind of like do it by hand like that too. That tends to be n minus r. What does this exponent also tend to be in terms of this?
R.
It's just r, yep. So a little formula for this exponent, it's n minus r, and for this exponent, it's r. But I like to show you kind of by hand why that's the case. Because when you kind of do descending powers, you end up with x to the 8, n minus r. And these two must also add up to 14. And if that's n minus r, this must be r, because they must add up to n. And so on. And on this page, we weren't using the gorgeous formula anymore. I said, let's practice using the calculator. So remember, alpha window, NCR. You can also press math probability and go to NCR as well. There's 2 different ways to get it. You type in 14 and 6 into here, and you got 3003. And then you plug that number there. So as I said, show this step because they love it in the exam. You get lots of marks for it. So show that little, they like to see you using nice notation. It's not wrong if you used NCR notation instead, but more commonly you'll see in the mark schemes they're using that. So they'll be easily able to follow your work if you do it with this. Then 3x to the power of 8, and the sign is important, so it's negative 4 over x squared to the power of 6 and so on. So we filled in those. And then you notice there was a little bit of exponent law stuff. So 3003 times that, but don't forget these three numbers together gave us a big number that actually didn't fit on your calculator, unfortunately. That's because I've made up the question. In the exams they'll tend to make ones that do fit on your calculator, because this is 10 digits and your calculator can only fit 9. But then x to the 8 over x to the 12. You have to use exponent laws a fair bit in this unit. X to the 8 over x to the 12. Remember, you subtract the exponents and keep the same base. So subtracting the exponents, you could have written this number, x to the power of -4, that would have been fine. That's the same answer. X to the power of -4 is the same as 1 over x to the 4. So you'll find in the mark scheme and the textbook, they'll probably write their answer like this. It's not wrong if you wrote this with x to the power of -4 as well. But you'll find that in the mark scheme, they'll tend to write it like that. So I'll tend to be writing my answers like that too. And so on. This is sort of where we're up to, wasn't it? Yep, it was. We're partway through this. This is the most popular question on your topic assignment and on past exams, this style of question, where instead they tell you not find the 7th term, not find the 3rd term, but find the coefficient or the term that matches x to the power of 6, and you've got a fraction going on. Yes, Krista?
You can also use the other way, right? This was just another strategy.
Notice the slight difference between this one. This one asked for the 7th term.
Yeah, but couldn't you just still find it and then just use the code, just write the coefficient and not extra?
If it was just a regular like x plus 5 or 2x plus 3y, it would be fine. But see how there's an x squared and an x in a fraction? So we're not sure exactly at what point, at which term, are they going to actually overlap and become x to the power of 6. So you could kind of just experiment and do the entire expansion if you wanted, but what I'm teaching you is a little strategy to just use a formula to get straight there. Yeah. And if it didn't have like something to the power of x or a square here, then it wouldn't be a problem. I'll show you one where it wouldn't be a problem. Is like on the previous page. See, there was just an x term. There's no complicated fractions going on or powers. There's just an x term, no complicated fractions or powers. So it is pretty obvious for this one. For those two, it's really obvious where you're going to get the x cubed term, because it's just going to follow this pattern. Whereas for these ones, there's going to be all this x cancelling out because of exponent laws. So as I said, you could do the entire expansion to work it out, but this is a quick strategy to tell you exactly at what value of r is it going to coincide and get x to the power of 6 by the time the exponent laws kick in. So we're only partway through this. And so in the expansion, you asked to find the coefficient of x to the power of 6. So the strategy I've suggested you use is, we know what n is. So n is 12, so sometimes in my little working out I make a point of writing n is 12, just to remind myself we know what n is. We're going to use this strategy to find out what value of r actually will give us x to the power of 6. So it's 12r over r. R is the thing we don't know yet. And the first term is x squared. And remember, n minus r, there's a little general formula for this. If you want to, you can maybe make a little point. This in general, remember, is n minus r. That happened on the previous page too, just to show you proof. See this term here? It's n minus r, 8 minus 5. And same with the above one. That one there was n minus r, it's 5 minus 2. This one was r. So back to here. There we go. So 12 minus r, because we know what n is, but we don't know what r is. The next term is 4 to the x, and that's the power of r. So it's always the case, n minus r here, and r is happening here. This is where it got a bit complicated, where we had to use exponent laws. 12 over r is still unknown, so I'm just bringing that down. And here I'm just using exponent laws to expand, like remember exponents of exponents. So like this, would you agree we multiply the exponents?
Yeah.
Yep. So that becomes x to the power of 24 minus 2r. A common mistake is sometimes people write 24 minus r. They forget it's 2 times that and 2 times that. And to help us make it more clear, we wrote it over 1. Beforehand, in my working out, I tend to not write it over 1, but later on it helps you to sort of see kind of how these two merge. And this one is 4 to the 1 over x to the 1. So multiply the exponents, it's 4 to the r over x to the r. Again, sometimes people commonly forget that it's x to the r. They just put the r on the 4. And then this is where it got mildly complicated, is combining these two. I'm still just carrying down 12 NCR, and I'm trying to combine these. So that times that over that times that is what's going on here, which I kind of vaguely did over here because I figured we needed a bit more space to do this one. So maybe I'll put an arrow to point out that this has been kind of written out the long way over here. So let's see, 4 to the r is just because it's 4 to the r over 1. So 4 to the r over 1, but with these two both have the same base. So we can use exponent laws on x and x. 4 to the r over 1, I've just popped here. These two combine though, so which we've kind of done over here. X to the 24 minus 2r over x to the r. Remember, would you agree you subtract the exponents and keep the same base? Yep. Subtract the exponents, so 24 minus r will give you 24 minus 3r. And that's how we got to there. So if you want, I'll leave that in there because, like, you know, this is the first time you've seen it, so it's kind of hard to see how that suddenly became that. And then the whole point of doing this is, this is meant to be our exponent of x. And what exponent of x do they want us to have?
X.
Yeah, x to the power of 6. So set this little formula equal to 6, which I've done in this box, and solve for r. The whole point of this was to find out what our r is. So set that little formula equal to 6. If they wanted x to the power of 3, we would set it equal to 3 and solve for r that way. If they wanted x squared, we would set it equal to 2 and we'd solve it that way, and so on. If they wanted the constant term, remember x is to the power of 0, so we'd set it equal to 0, which we'll do for that part B. So we end up, all of this was just to find what r is, and then once we've got r, it's not so bad, we can just sub it in to here. You can even, sometimes in my working out when I did the topic assignment, I just went straight back to the original and did it from there, but you could just sub it into here instead. That's what they tend to do in books. So we know it's not 12r, we know it's 12.6, and then we can use NCR on our calculator to find that 12C6 is 924. 4 to the power of 6, because r is 6, is just 4096, and x, if you want to double check, you could always double check by subbing in your r is 6, just to confirm you're getting x is 6. That's okay to do that. This, by the way, here was for the next part B, so ignore the yellow bit, that's for part B so far. And then multiply that and see we get a big coefficient. This time they didn't just ask for the term, they asked for the coefficient. So I would write out the whole term. That's just what I like to do, write out the whole term and then write the coefficient as my final answer. To be honest, you could have gone straight to the coefficient, you didn't have to write the whole term, but I just do it that way. Were there any questions about that? Because that's a lot to take on for Monday morning. Just keep moving. All right, cool. Right. Now we're on to doing the constant term. So there was a little bit of confusion. People were a bit confused. Why is for the constant term is the x to the power of 0? Why does that generate a constant term if x is to the power of 0? Yeah, it means there's going to be no x anymore. So we're just reminding ourselves that a constant term is a term where there's no variable in the term. So we need the x's to cancel down. So basically the exponent will have to be 0. So this is for part B. So we might want to make a point that this is kind of starting part B here. So question B, we're starting here. So 24 minus 3r, see it's the same formula. There's no point doing this again from scratch. It's still the same situation. We've got 12r, 4 to the power of r, 24, 20 minus 3r is our exponent. But this time, instead of setting it equal to 6, because it's a constant term, we set it equal to 0. As for the constant term, the exponent must be 0. It might be worth putting a little note for that. For the constant term, the exponent must be 0. And then, I think we did this really quickly, but right at the end of the lesson, Then when you solved using the formula for the exponent for x, we ended up getting r is 8 this time. And now we need to just finish it off by actually like just plugging in r is 8. So we know it's 12 eighths. So we're going to need to calculate using our NCR. 12 C8. And then we can go back to here and just work it out from here. X squared, 12 minus r, 4 over x and everything. Or you can, if you trust what you've done here, then you can just sub it straight into there. 4 to the power of r. So our r is 8 this time. So it's 4 to the power of 8. I'll do it in yellow just so you see where the 8 comes from. It's going to be a big number. And it's going to be x to the power of 0. It's fine if you want to skip x to the power of 0 because you know that's 1 anyway. So it's going to be a constant term because x to the power of 0 is just 1. And I'll let some of you guys try plugging into your calculator. Let's see if we get the same answer. You get a big number. You get numbers in like the 30 millions.
Yeah.
We could like watch the blue number first if you want. You get 495. Oh, what did you get for 12 C8? You get like 30.
Yeah, 32 million
Yeah.
440,300.
Perfect, yeah, that's correct.
C8 is 465.
465? 95, yeah. Do you get 495 always? So alpha F2 is one way to get there, or math probability. What's 4 to the power of 8?
65,536.
It's horrible, isn't it? It's big horrible numbers. 6, 5, 5, 3, 6. It's a kind of topic where, if you want, you can put in 1. X equals 1. And then, like I said, there is no x anyway. 3, 2, 4, 0, 3, 2, 0. That's our final answer. They just wanted to know what is a constant term. It's a positive too. Makes sense that it would be a positive. Let's see. Because your r is 8 and, oh well, they're both positive terms anyway, so ignore that. So yeah, it's getting pretty algebra intense right now. It's kind of good because you're practicing your exponent laws. What are we on to now? 1, 2. Anyone? Some people are still writing down stuff down. So leave that. Just the people writing stuff down still. Now we're onto the extra challenge questions, are we? No. Yep, extra challenge problems. The next one on page 19, a bit similar to one on the topic assignment as well. There's just one that pops up on the topic assignment in this kind of style. Anyone still writing? No. This is the kind of topic where your eyes can see a calculator and see numbers on a calculator and get mixed up. So really like double check what you're seeing. Like it's really easy to, like what happened with Lauren, say 465 instead of 495, because you're just seeing lots of numbers and lots of digits. So it's the kind of thing where you want to kind of just double check what you're seeing on your calculator screen too. Yes, Grace.
Just on the last question.
Yep, sure thing. Yep, let's go back.
I thought the exponent would be on just 12/6.
For part B?
Yeah.
Oh, she put 12 A. No.
Yeah, for this one, 6 is the exponent for part A. As in, like, 6 is the value of r, sorry, for part A.
No, but if you, I don't know, I might be doing wrong, but I worked
That's
it
good.
out and my case was from 24 to 20 to 16, so it would be decreasing by 4.
Oh, you're talking about your powers of A. And then don't forget, because of this term here, you're also going to be cancelling out x's from that as well, yeah.
Yeah. So the first exponent, wouldn't that be 24?
X to the 24, yeah, because then it's going to be this to the power of 0, isn't it? Yeah. Then 20, oh, because you're dividing by x, but don't forget it's going to be, this is going to be then times this to the power of 1 as well. So this to the power of 11 and that to the power of 1, would that make x to the 21? Because that'll be 22. And then you're going to be timesing by that, yeah. And so that's why doing it manually can be kind of really hard. But doing it the long way, doing the long expansion, is a good way to double check your answers. If you've got the time and the energy to do the long expansion like Grace is doing it from scratch, that's a really good way to check your answers and just feel like a little bit more confident that you've got the right value. So this is more a shortcut. Okay, so find the coefficient of x5 in the expansion of this BIZO. So what's different about this is you've got two terms, but notice the exponent only belongs to one bracket.
Does that mean that you would just have the x plus 3 as like
Yeah, exactly, yeah, good point. That's more like an afterthought.
Okay.
Yeah, so the binomial expansion only applies to this second bracket. And as, yes, yep.
So you go to the x5 to the x plus 3 bit.
Yeah, so we're not going to look for x to the 5 from here. Instead, we've got to think, okay, once you worked out this big expansion, to get the coefficient of x5 from this overall thing, it's going to be that times the x to the power of 4 term, and that times the x to the power of 5 term. Does that make sense?
Yeah.
No, I can understand that. So we've got x plus 3 here, and then you're going to have a big, imagine you had a big expansion here. So that big yellow thing is being expanded. In order to get the coefficient of the x5 term, there's two terms we're going to have to add together. We're going to have to add together x multiplied by the, whatever, x to the 4th term. Because do you agree that that's going to generate an x to the power of 5? And also this times, what do you think it would be multiplied by? And it's probably going to be earlier. So x to the power of 5 term. So which is, to be honest, probably going to be more this side. Because a constant times an x to the power of 5 will make an x to the power of 5. And an x times an x to the power of 4 will make an x to the power of 5. And then we have to add those two terms together. So what we need to find from here, would you agree we need to find the x to the power of 4 term and the x to the power of 5 term? And then those two terms, we need to multiply that one by x and that one by 3, and then add them together. And that will give us the overall x to the power of 5 term. The other option is, if you're really worried, just do the entire expansion and then just work it out. But that takes a long time. Yeah, you can totally do that. Just do the entire expansion and then work it out from there. That times that, that times that. And you could totally do it that way. But if this is, we like to show you sort of the shorter ways too, because I like to kind of let you know, like see that you can do the shorter versions as well. So we need to find from here, I'll just make a little plan of 2x minus 1 to the power of 6, thing that I underlined in yellow.
What do we do now?
We need to find the x4 and the x5 term. And just reminding you that it's because of bed mass. It's because of bed mass that the binomial expansion is what we deal with first. Then, like Isabella said, this being multiplied in is therefore an afterthought. Because exponents before multiply. So what we do is we separately find the x to the 5 term and the x to the 4 term. Yeah. So maybe let's start with the x to the 4 term, because that's the way I chose to do it, no real reason. So for the x to the 4 term, you can kind of think, according to this, if this expanded, it's kind of a nice one. There's no awkward fractions or anything going on. So you just know the first term's going to be an x to the 6, and next one's an x to the 5, next one's an x to the 4, and so on. So binomial coefficient for the first one, which agree is just 6, 0. And then we're going to need 6, 1. We're going to need that when we do the x to the 5. And 6, 2 is what we need for the x to the 4 term. So if you wanted to, you could almost like split it into 2 halves and work out the x to the 4 term here, the x to the 5 term there. I kind of split into 2 blocks here. So I decided to find the x to the 4 term first. So that's using 6, 2. So I'll make a little heading for the x to the 4 term. Let's work it out here. So it's dealing with 6, 2. So that gives us the x to the 4 term. That's a little binomial coefficient. And in colours. The first term, what should that be to the power of?
4.
Yeah, good. And how did you get 4?
That's okay.
Yeah, n minus r, good. So n minus r is our general formula for this one. N minus r is 4. This one in purple. Second term is negative 1. So again, that's important. And you remember that's just r. And 6, 2. We can just use our calculator for that. What do you get? You could use a gorgeous formula, but I think you're pretty good with that by now. An odd number, 15, yep. So make sure you do all this business. 2x to the power of 4, what does that become?
16x to the 4.
Good, yeah. 16x to the 4. Negative 1 squared. Gives us 1, yeah. Negative 1 squared, it's okay. If you didn't want to write the 1 there, it's okay. It's pretty obvious. So then do you get 240 x to the power of 4? So that one's kind of done. So I'm going to just subdivide that off if you want.
Okay, so what happens to the other bracket?
That this term is going to be multiplied, because it's x to the 4 term, it's going to be multiplied by an x. So overall this is going to become 240 x to the 5. But we've got to add it to that multiplied by the 5th term as well. So I might just work out the 5th term now and then kind of deal with what it's going to be like when we expand it in. Like I'll rewrite this bracket with those 2 terms put in there, just to point out that that's what we're expanding. So under here I'm going to work out the x to the 5 term now. The x to the 5 term. So as you can see above, our little binomial coefficient 6, 1. What we're using. Hopefully. 6, 1. What's going to be my exponent on 2x? 5, yeah, good. N minus r. And what's going to be my exponent on negative 1? 4, 5, r in that case. So is the overall term going to be positive or negative? Negative. Negative, good, yeah. So that. 6, 1, do you get?
6.
6, good. 2x to the power of 5, what does that become? 2, yeah, so you're going to get very good at your powers of 2 and 3 and so on, and times by negative 1. So you're hopefully going to get, do you get like a negative 192?
Yep.
Cool. X to the 5. So we've found those 2 terms. Now let's set up this expansion again, like I did at the top, but we'll do it maybe on the side. What is it again? X plus 3. Don't be like me when I first did it and write x minus 3. I have to do it all again. X plus 3. And then in the whole big expansion, we would have had an x6 term. Doesn't matter what that is though. We have an x to the 5 term. Negative 192, x to the 5. We have an x to the 4 term. There's a plus 240, x to the 4. And there would have been all sorts of other terms in there too, but we don't need to put those down, so we just simply need to decide when Max multiplied, oh, I multiplied by the wrong one. That one gets an x to the 5. That one gets times by x to the 4, because then that's going to generate an x to the 5. Which is nice, just 240 x to the power of 5. And then this one here too, could be that one times that one. What's 3 times negative 192? Yep. And then we just combine those left terms. Does it give us a positive or a negative? So why might I lose a mark just for the way I wrote my answer?
It's actually coefficient.
Good, yeah, they want the coefficient. So just be aware of that. Always go up and check. They alternate a lot between find the term and find the coefficient. They're just testing, do you know what a coefficient is, are you reading it properly and all that kind of stuff.
How do you say that x into x plus 3 is linked to the x4?
Oh, as in like, I try to think x times what kind of term would generate an x to the power of 5. And
Okay.
the only thing I could times an x by would be an x to the 4, and that's going to generate an x to the 5.
Okay.
So yeah, so what I'm thinking about is these two things times what kind of terms is going to generate an x to the 5.
Okay.
Yeah, that's exactly all I'm thinking about. And it's because and if you were in doubt, just do the entire expansion and then you'd probably work it out. It's just a shortcut method. As I said, there is one like this in the topic assignment, but I think it doesn't have a bracket here, it just has like an x squared or something there, or an x, and you just have to bear in mind to do with that expansion and then think that times what would have made the term I'm asking for.
So it is 336, not 366.
Oh, yeah. Be careful of doing things like that. It's weird. 336. Negative 336. So you can get number fatigue doing these kind of things.
Number 50?
Yeah, I think you get number fatigue. You see a lot of digits when you do these kind of problems. Okay. So as I said, this was an example of a more challenging problem than normal. And here's another example of a more challenging problem.
Just the hardest to get.
Yeah. Yeah, the last ones, these are just examples of real doozies. Like really unusual things that you tend not to really see in exams, but they've popped up in textbooks and stuff, so you never know, they might put in an exam. So in the expansion of 3x plus 1 to the power of n, the coefficient of the x cubed term is 270. Find the value of n. There are some questions in the topic assignment where they tell you the coefficient and they want you to solve for something, but not normally ones that are as difficult as this, where they don't tell you the n. Normally they'll have told you the n. They're just asking you to work out something in here, which is actually quite easy. It's not hard to do at all. Okay, so this is taken into account. You notice that when you're doing Pascal's triangle, don't bother writing these down, but don't write these down. What do you notice about something special about the rows, apart from like they're just putting the wrong number there, apart from the fact that they're the sums of the two numbers above them? What's something interesting about each row?
1, 2, 3, 4.
Yeah? Oh yeah, that's true. And I'll try to give you a clue, something in particular.
It's symmetrical.
Yeah, symmetrical, yeah. So this kind of problem sort of helps if you kind of just are aware that this term here is the same as that term there. And that term there is the same as that term there. Similarly, the next one would be 1, 5, 10, 5, 10, 1. So it's 1, 10. What did I do? Oh, oh dear. 10, 5, 1, cool. So just pointing out that, say with this one, 1, 2, 3, 4, 5, 6. So that's like 5, 0. This one here would have been 5, 5, 1, 5, 2, 5, 3, see a connection between this one and this one? They're just the same number. And there's a connection between this one and this one. They're just the same number. Yeah, there's always that too, yeah. So if this one, first of all, you would think of this one as NR. So would you agree that NR is the same as N over N minus R? They're the same thing. So NR is the same as N over N minus R. Same with that one. NR is the same as N over N minus R. So it's sort of like what Lauren was pointing out, that these two add to give N. Because N minus R plus R does add to give N. So that's a little thing that might help kind of like in conceptualizing this kind of problem.
We just say NR and then
Just N minus R. Yeah, there's no new letter for it yet, good point. It would just be NR is the same as N minus R kind of thing. So maybe I'll just take a little snip of it and I'll leave that on the side. I'm going to erase it now, but just in case it's ever useful to look back on, if we're doing notes, I'll just take a snip of it. Oh, great. Why did that happen?
It was funny.
It keeps going back onto the pen. Have I got the pen lifted off or something? So I'm just going to...
Pretty huge.
Yeah. Yeah, not wrong. Let's make this small and just move it to the side. Okay, then I can erase that. There you go. Leaving this just on the side somewhere in case we ever happen to want to refer back to it. Might not. Okay, now here's the beginning of this rather complicated question. So, as I said, this is a reasonably complicated one.
Well, technology is beautiful. So you just move that. That's awesome.
you just press the up and
Yeah.
you can't. It's
And then
screenshot.
just snip it.
I can do this. It really bothers you. It bothers you, doesn't it?
Oh, smart little lady. What?
Are you sure? I'd say now's not a good time to get water. Without getting into a really tricky one. And hearing it the first time, you might still not totally get it, but at least you would have heard it the first time. And then the second time, you might get it. Okay, so, and we've only got like about 10 minutes to go. So in this expansion, it was found the coefficient of the x3 term is 270. So let's try to see where would the x3 term have occurred, as in like, what will be the exponent on the first term? On x, what would be the exponent on the first one?
Oh.
That's the n, yeah.
3x to the power of n.
And subtract 1.
I've got to know that.
And then dot dot dot. Oh, I just wrote n x to the minus 3. Yeah.
The longest one was 2 pieces. The longest.
That is x to the n minus 3. Sorry. Yeah, and subtract 4 dot dot dot. And then eventually we want the x to the 3 term. So then there'd be eventually we'd get to it towards the end is when we're going to get to x to the 3, x squared, x to the 1, and remember the last one, x to the 0. So we want to know, so there's a lot of things.
But that's the same thing as that.
What would happen to the n?
Yeah, we don't know what the n is, but we want to get to that.
Wait,
We want the x cubed term.
so that is equivalent to that. So I can put little equals to that.
Yeah, so good. So what did you just point out then, Krista?
That is equivalent to...
Its binomial coefficient will be the same. So this is the one we want to find it for. Yeah, so this is the one we want to find it for. But it's going to be the same as that one.
It's going to be, so x to 3 is the same as what? That one.
Yeah, because when you do the little binomial coefficients, I probably should have written this below. Like that, would you agree is going to be n0? This one's going to be n1. n2, n3, dot, 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 and then this one would have been n to the n minus 3. This one's going to be n to the n minus 2.
Okay.
Oh, we can see here it's parallel.
Yeah, because of that symmetry. Yeah. Remember, like that kind of like dot 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 dot. Talking to the symmetry.
So we should have kind of wrote down this
If you want. I'll give you a bit of time. I'll just leave it on the side for you. So it's all because of. I'll make a actually written sentence about this right here. Rows in Pascal's triangle are symmetrical.
There's no
Oh, you remember the last term is always like 5, 5 or 6, 6.
I can't even get that.
Good point.
It's not easy, you know.
That?
Yes,
No, there's been no
that's
talk
it.
about a test at all. Not yet.
It's a 6 to 9.
Definitely before December break.
And then they-
So rows in Pascal's triangle are always symmetrical. So you could write, so therefore we can write this thing. N over R is the same as N over N minus R. So here we're just kind of writing what we kind of found there as a sentence kind of thing, because it's going to help us for finding the x cubed term. We're going to need, instead, because we can't work out what N over N minus 3 is, but we'll be able to use N over 3 in its place. We'll be able to replace this thing with N over 3 instead. So we will use N over 3 in the place of N over N minus 3. So see what I've got written on the top. We're going to use N over 3 in that place. Just going to be easier to deal with later on down the road. So then we're going to now we're going to finally start to set up our binomial expansion. So we're going to, instead of writing N over N minus 3, we're going to replace it with N over 3. If you want to, you can write it first with N over N minus 3, if that helps. And then the first term, would you agree, is
in the place of.
Oh, do you think I don't need, you can write it once, I just, I'm already going to run out of space. So we've already decided to replace it with N over 3, so let's go straight to replacing it with N over 3. And then 3x to the power of 3, because the first term, we need x to the power of 3, and the whole problem is 3x plus 1. So 3x to the power of 3, because we know it has to generate an x cubed, and it must be 1 to the power of n minus 3, because that's what r is.
Yeah.
Like if n was 8, then that would be 5. If n was 9, that's going to be 6. Yeah, because at the moment we don't know what n is.
Oh yeah, because it's second.
Yeah, and those have to add up. And would you agree that the purple part overall is just going to equal 1? Why? So Owen, why must the purple part equal 1, no matter what n is? Poor Owen, because it's picked on right then. Anyone can help Owen. Help Owen if you want.
Owen kept up.
You just got Anyone can help. Anyone else can help. You've got the hiccups. Yes, Krista.
Because. Never mind. Because. You know, true, but. Because it has to be x to the power of 3, right? Never mind. I'm not the right person.
That's fine, Isabel.
1 to the power anything is equal to 1.
Yeah.
Like 1 to 1.
That's right, yeah. As 1 to the power of anything.
But why do you want it to do 1 then?
You don't want to do that as games because
1 is in your equation, so you have to use 1 and you just know the answer will be 1.
Yeah.
Shouldn't it be 0 though? Because you're trying to find the direct term. So it doesn't have to be.
Yeah, and also, but notice one thing we've found. We're also told that the coefficient's 270.
Yeah.
So the good thing is we're going to be able to cancel out the 1, ignore the 1, and set this thing equal to 270. And maybe use a bit of, and maybe use the gorgeous formula as well. So therefore this simplifies to, helps,
I don't get that part.
n over 3. You still don't know what that is. This being 3x cubed, what will the red thing become? 27x cubed. That's right. Now let's maybe set up our gorgeous formula. Gorgeous formula, remember? N over r equals n factorial over r factorial n minus r factorial. So n factorial, you might remember back to lesson 2, you came up with a good expression for n factorial. It'll be n. Yep, okay. N minus 3. I just wrote it n minus 3 instead of 2. Yep, n minus 1, n minus 2. N minus 3. N minus 4, and so on.
What?
Maybe I'll do one more. So remember the gorgeous formula? So this is.
Oh, so you're doing n factorial.
Yeah, exactly. And you'll probably find heaps of things are going to cancel out. So we're doing n factorial over r. We know what r is. R is 3 in this case. Or it's the
How
same
did you
thing.
know that to stop this from learning?
Oh, you just put a dot, dot, dot.
But why?
I think because I noticed on the bottom, n minus 3 factorial is going to be this thing. This is going to be n minus 3 factorial. And I wanted to just to show that I can cancel out 2 things. You'll see. All right. Yeah. It sounds weird right now. So 3 factorial, 3 times 2 times 1.
I don't get finished right on time.
So, Wood just seems to be freaking out now. Okay, I'll just quickly close and open it again. I'll try to finish this just before we're done, because we're so close to being there.
Oh, because you ran up to it, you can go for a second time.
No, I don't know why. It just freezes every now and then. And the only thing you can do, like I've messed with it, and the only thing you can do is open and close it again. Okay, so we should go up to right at the back. We're sort of around here, aren't we? Okay, so then the bottom bit, and then you have n minus 3 factorial. Did you have times? N minus 3, yeah.
N minus 2.
N minus 4 would be the next one, good guess. N minus 5, dot, 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 dot. So, and then don't forget you've got 27. Yeah, and then don't forget you've got times 27 x cubed here. And now this is important. What's cancelling out?
N subtract 4, N subtract 3.
Yep, and of course the n subtract 5 as well, will it? Because that's a dot, dot, dot. N subtract 3. Good. Anything else? No, you're good. What did you have a question about?
How did you go from 1 to n minus 3 so easily?
Oh, because that's that's r factorial.
Oh, n minus r.
And that's n minus r factorial, yeah. So perhaps you might want to write that, equals n factorial over 3 factorial n minus 3 factorial. That might help. That's where that comes from. And then 3 times 2 times 1 gives you 68. And then times 2 times 27 x cubed. They've told us that the coefficient is 270. So you could have always, along the way, written equals 270 x cubed. But you've kind of got all this other stuff going on, so I'm just only starting to introduce it now. So they told us in the question that the coefficient of the x cubed term is 270. So we're going to be able to solve for n. Lots of different ways you can start to solve for n.
You can multiply 6 out.
You can divide off 27, you can cancel the x cubed.
Let's cancel x cubed.
Cancel x cubed, okay, yeah. You can do like what Sarah's saying as well, divide by 27, can do all sorts of things.
We can cancel 27 capital H, put 10.
Mm-hmm.
Okay, let's do that as well.
Yeah, do that, that sounds good. I'm being lazy, do it all in one big step. So then you're going to end up with n minus 1. At some point you're going to have to do some foiling, of course. Although it's 6.
That becomes
10, yeah. And then times that with 60. So amazingly it keeps the stuff cancels down, doesn't it? N minus 1, n minus 2 equals 60. Did you get?
Yeah.
You might want to foil, do some foiling and all that business. N times. When you foil all this, you want to be really good at your foiling. That's going to give you an n squared. Thank you. Yep, almost there. We're nearly done. We're so nearly done, and we just started. So when we foil this, what do you get?
N squared subtract 3n plus 2.
Good. Well done. Subtract 3n plus 2 equals 60. And then factor that in, you'll get n cubed minus 3n squared plus 2n. I'll just go straight to minus 60 equals 0. And now you're going to have to get your calculators out and grab out polysmol. Because it's a cubic. So yeah, it's an app. Polysmol, polyroot.
Oh, it's just graphing, right?
Oh, you could solve by graphing too, actually. I didn't think of that.
No.
But this is a quick one for when you're solving quadratics or solving yeah, that kind of stuff.
Alright.
Polyroot finder. So, and remember, I would say try doing it now. You're probably used to quadratics. Have you solved many cubics before?
Well, not many, but we know how to do it.
Do you know what you have to change to make it a cubic?
Yeah. The what?
The order or something, isn't it?
Yeah.
Wait,
Do you want me to show you?
five.
You got 5. 5 is correct. 5 is correct. In case anyone's not sure, you can start backing up. In case anyone's not sure, I'll just quickly show you on polysmol how we did it. So for the purpose of the video. So if you did it on this one, Krista, we'd go apps. Polysmol is the 4th one. And then I would just press enter. Then I'd select polynomial root finder. Press if you go, it's fine. And it's order 3 because it's not a quadratic, it's a cubic.
It's a cube.
Yeah, cubic, yep. And then I'd go next. And then I have to enter in the coefficient of the cube first. I see I've done this already, that's what's already in there. -3, 2, and -60, and then solve. And there's only one answer.
Yeah.
Yeah.
And it just gives you 5.
Yep.
Okay, I have a question this morning.
Yep. So n equals 5. And that's all they wanted. That's all the question wanted. They wanted n equals 5.
Two?
Cool.